Welcome to the video lecture by Dr. Biju Vastevan for JUC students. Here we're going to discuss the topics for week 9, which is 11.8 cylindrical and spherical coordinate system and 13.1 functions of two or more variables from calculus 3 math 211. Here we go. This page gives an idea about three different coordinate system of three-dimensional space. First one is a rectangular coordinate system. Second, B, the figure in B gives the idea about a cylindrical coordinate system, and C gives a spherical coordinate system. And the Cartesian coordinate system provides rectangular coordinate system provides a straightforward way to describe the location of points in space. Some surfaces, however, can be difficult to model with the equations based on the Cartesian system. This is a familiar problem. Recall that in two dimensions, polar coordinates often provide a useful alternative system for describing the location of a point in the plane. Particularly in cases involving circles, we use polar form. In this section, we look at two different ways of describing the location of points in 3 space, both of them based on extensions of polar coordinates. As the name suggests, cylindrical coordinates are used for dealing with problems involving cylinders, such as calculating the volume of a round water tank or the amount of oil flowing through a pipe. Similarly, spherical coordinates are useful for dealing with the problems involving spheres, such as finding the volume of domed structures, etc. When we expand the traditional Cartesian coordinate system from 2 dimensions to 3, we add a new axis called Z axis for the third dimension. In this way, for polar coordinates, starting with the polar coordinates, we can say that we have the repetition of the same process to create a new three-dimensional coordinate system for cylindrical coordinates. In this way, cylindrical coordinates provide a natural extension of polar coordinates to 3 dimensions. Of course, you can see that from the given graph, the location of a point in 3 space is described using an ordered triple, in which the coordinate represents a distance in distance. In the case of x, y, z plane, x, y, z can take any value from real number field. But in the case of cylindrical coordinate system, r is positive and theta is allowed to take any value from 0 to 2 pi. That is, in cylindrical coordinate system, the location of a point in 3 space is described by using two distances r and z and an angle measured theta. But in spherical coordinate system, we use an ordered triple to describe the location of a point in space. In this case, the triple describes one distance and two angles. One distance is the radius of the sphere rho, and theta is the horizontal angle and phi is the vertical angle. Theta is allowed to have the values from 0 to 2 pi, and phi can take values from 0 to pi. Now we are going to derive the formulas for the conversions from rectangular to cylindrical and from cylindrical to rectangular, and again from cylindrical to spherical and spherical to cylindrical. Finally, rectangular to spherical, and then from spherical to rectangular. There are 6 different formulas that we are going to derive in the beginning of this chapter. Okay, let's have yet another different graph now to derive these formulas. So you can go through these 2 videos to find more graphics about this 3-dimensional space of cylindrical and this spherical coordinate system. Of course, here we go again. We get this graph, the same graph, A has been expanded here, right? Okay, fine. Let's go through the system again. Find this is a point P expressed in 2 different ways. First one is rectangular coordinate system. This is cylindrical coordinate system r and theta. Now we find the conversion among them, and we know this is just extension of cylindrical coordinate system, just extension of polar coordinate system in two-dimensional case with added z. There is no change in the value of z between these two coordinate system. So here we are converting from x, y, z to r, theta, z, and we'll be back. We'll be back, right? Fine. We know in polar coordinate system x is equal to r cosine theta, y is equal to r sine theta, and we understand that there is no change in z. Z remains the same for both the coordinate system, isn't it? And when you find x square and plus y square, take the square root, you will get r, and theta theta is tan inverse y over x. So this one, the first one, is a conversion from r theta to, so this part r theta z. When I am given r theta z, I will find x y by using these two formulas. And of course the counterpart, when I get x and y values, I can find r and theta. So we are coming back to r and theta by using this formula. So two formulas, in both the cases z remains z. So this is the formula of conversion from rectangular coordinates to cylindrical coordinates, and from cylindrical coordinates to rectangular coordinates. Fine. Let's see the other version. Let's be back to the next graph. Okay, this one. Here the point P has been represented in two different coordinate systems. First one is spherical coordinate system, second one is cylindrical. Okay, now we are going to run between these two systems. Spherical will have rho, theta, phi, and cylindrical will have r, theta, z. You see, the theta is common for both the coordinate system. There is no change in theta, so we don't need to worry about theta. We need to find rho and phi if I give you r and z. If we get if I get rho and phi, we can find r and z. That's it. Conversion, right? Okay. From this figure given here, you notice that a point P in spherical coordinate system will be represented by three parameters: rho, theta, and phi. What is a rho? Rho is the radius of the sphere. Radius of the sphere here. This is the rho, isn't it? Okay. The angle theta is a horizontal angle that the projection of this radius rho on the ground, which is r, makes an angle theta with the x-axis. This angle is theta. This is same for cylindrical coordinate system as well. There will be a circle, base circle here, whose radius and angle will be r and theta. Right? Z is this height. So when there are two parallel lines, and when you intersect these lines by another line, these two angles are same, isn't it? This is a rule in geometry. So we can use the rule here to identify that if the angle is given as phi, the radius makes an angle with the z-axis. We call it phi. So if this angle is phi, then this angle is phi, right? So when I know that the opposite side of this angle is, or the adjacent side of this angle is z, because z is here as well, we can find a cosine theta. We can find a cosine theta, cosine phi from this one. Cosine phi is adjacent side z over rho. This will give you the formula for z. Z is rho cosine phi. one row we have derived. Next, in the similar way, if you find sin phi, you will get r over rho, which is r is equal to rho sin phi, and in both the cases theta is theta, isn't it? So there are three rules. Now you can find r theta z, r theta and z. So we will find r theta. So this is a conversion from spherical to cylindrical. So this part has been done now. The converse part will be done right now. When I get r theta is that how to find a rho theta phi. Theta is same, so no change happens in theta. We have to find a rho and phi. Just like the conversion between polar and rectangular coordinates in two dimension, we can do the same here. To find rho square, we can to find if you find z square and r square, you will find rho square from these two equations, equation number 1 and 2. If you find z square and r square, right side you will find rho square. So therefore, what is rho? Rho is square root of z square plus r square. In the similar way, we can find one more thing. Equation 2 divided by 1. 2 divided by 1. What do you get is tan phi. Tan phi is equal to r over z. Therefore, this is one rule, and this is phi is tan inverse r over z. So these two equations 3, 4 along with theta is equal to theta converts all points on the cylindrical coordinates into spherical coordinate system. So that's it. So we have seen 4 different conversions. The rest remaining is spherical to rectangular and rectangular to spherical. Okay, here we go. Again, we are back to see how to convert from spherical is rho theta phi to rectangular coordinates x, y, z, and back from rectangular to spherical. So the other way is to be found, isn't it? So in the previous part, we have seen that z is equal to rho cosine phi, r is equal to rho sin phi, and before that we have seen polar coordinates. X is equal to r cosine theta, y is equal to r sin theta. So when you substitute the value of r in both the equations, you get x is equal to rho sin phi cosine theta, and this way y is equal to rho sin phi sin theta. The question is, what is z? Z is given here. So these three formulas call it A, B, and of course C. These three formulas A, B, C will convert from spherical to rectangular plane, plane, isn't it? Fine, in three-dimensional space. So if I know rho theta phi, I can find x, y, z by using this formula. How to come back? Second part, finding rho theta phi. Rho is obviously the radius of the sphere. You can find x square plus y square plus z square, just like we do in the case of two-dimensional polar coordinates. X square plus y square is equal to r square. In this way, you just try x square and y square and z square, sum them up, you will find rho square. So you will get rho is square root of this x square plus y square z square. So we found rho. The formula to find theta is very similar to that of polar coordinate system. Tan inverse y over x. This is another rule. This is one rule. We can call equation number a1 b1, and we need to find a formula for phi from c gives cosine phi is equal to z over rho. So obviously phi is cosine inverse z over rho. This is another formula. Call it c1. So this a1 b1 c1 will give you three formulas for conversion of xyz into rho theta phi. That is it. Now all the results have been tabulated in this page. You can find cylindrical to rectangular, rectangular to cylindrical, just like the polar coordinate system, and then spherical to cylindrical, cylindrical to spherical here, and finally spherical to rectangular, rectangular to spherical. All the 6 formulas have been summarized on this table. Okay, fine. We will go to the exercise. Some general shapes of three-dimensional space: cone, cylinder, sphere, paraboloid, hyperboloid have been given on this page with the equations of this shape in 3 different coordinate system. First one is rectangular coordinate system, cylindrical coordinate system, spherical coordinate system. If you know one of them, you can convert to the other. If you know z is equal to the first case, if you know z is equal to square root of x square plus y square, and we know this value is r square, so z is equal to positive square root of r square, which is r. So z is equal to r is a cylindrical coordinate system. Now if from z is equal to r, when you substitute the value of z is a rho cosine phi, which is equal to rho sin phi. You will get, when you divide by, and this equation when you divide by rho cosine phi, you will get 1 is equal to tan phi. You will get from this one, you will find that phi is pi by 4. So from one to other coordinate system we can move. If you know one equation, from the given known equation we can find the other 2 coordinate system. That is it. You can go through this page and you can check other results as well. Of course, now we are moving to exercise set 11.2, converting the points, not the equation, converting the points on the polar on the 3-dimensional space. If I give rectangular, this first case, convert from rectangular to cylindrical. So here we go. This is an important case for you guys. Of course, the solution starts from writing rectangular x, y, z to cylindrical. Cylindrical coordinate systems are r, theta, z. R and theta will give you the base circle, and z will be the height, so it will be a cylinder, isn't it? It will be a cylinder. When you collect CDs one upon the other, it will form a cylinder. That is it. One, if you have a circle and with some height, you will get the cylinder. So okay, let's choose one problem here. Which is looking difficult to you. Maybe all are easy for me, but yeah, you have to think in your point of view. Let's choose C. I will solve one problem, all the 3 remaining will be your practice problems. C. Okay, because what is the reason I have chosen this one is x is negative. When x is negative, finding theta will be slightly different, isn't it? Okay, what is the formula for r? You are looking for r, theta and z. R is nothing but square root of x square plus y square. Theta, the formula for theta is tan inverse y over x, and z has no change, same z. So what is z given here? This is given x, y, z is given here, isn't it? X is negative 4, y is 4, and z is negative 7. So this is a negative 7. Fine. R is square root of negative 4 square plus 4 square. You get, what do you get? Negative 4 square, 4 square. Can you tell me what is it? 16 plus 60. Yes, of course. 16 plus 16 root of square root of 32. That is it. You can leave it square root of 32, or if you want to simplify, you can write 2 times the 16 and 4 of root 2. This is also possible, otherwise leave as root 32. Here, tan inverse y over x. Tan inverse y, 4 over negative 4. So whenever x is negative, you should be careful about the code. So I am writing here, x is negative. X is negative in this side, y negative 4, y is positive 4. Your point is on the second quadrant, but this will give you, by using calculator, you will find tan inverse negative 1 is negative pi over 4. The angle is in the fourth quadrant, but that's not the true one, isn't it? So you have to turn back 180 degree, add pi. So the angle theta is 3 pi over 4. So we have found all the three, is it theta and r, all the three. So the answer should be listed as the triplet, ordered triplet, right? 4 root 2, 3 pi over 4, 3 pi over 4 is theta, and z value is negative 7. That's the end of this case, and let's move to the next case. Okay. Convert from cylindrical to rectangular coordinates. Cylindrical to rectangular coordinate system. Okay. First, when we are looking for solution, we write the formula, isn't it? We want from cylindrical r theta z towards, we are working towards x, y, z, and we have to find x. We have to write the formula for x in terms of r theta. We know the polar coordinate system. What is it? X is r cosine theta, y is r sine theta, and there is no change in z. There is no change in z. So z, which is our choice? Shall we go with problem number 4a? 4a. Okay. So this is r, this is theta, this is z. No change in z. So z is 7. No change, isn't it? We are supposed to find x and y for this case. X is r is 6 cosine 5 pi over 3. Just use your calculator. Type this 6 cosine 5 pi by 3. You will get the answer as 3, because this is 6 cosine 5 pi by 3 will be equivalent to 1 over 2. You get 3. Check using your calculator. And in the case of y, which is r, 6 sine pi 5 pi by 3, sine 5 pi by 3, this is 6 times negative root 3 over 2. So the answer is negative 3 root 3, isn't it? Let's verify this answer. So finally we write the answer as an ordered triplet. What is it? X is 3, y is negative 3 root 3, and z is 7. That is it for this case. And now we are going to discuss a different problem convert from a rectangular to spherical coordinates. From rectangular to spherical coordinates, right? So first we need to write x, y is this is rectangular coordinates. We need to write spherical coordinates system rho theta phi. Rho theta phi. Now we have to write the formulas for rho theta phi in terms of x, y, z. X, y, z. So what is rho? Rho has been written as square root of x square plus y square plus z square, isn't it? And theta is usually tan inverse y over x. Theta is usually tan inverse y over x, and phi is cosine inverse z over rho, isn't it? Z over rho. Rho value can be found from this rho value. You can use it here, right? Fine. What is rho? What is the choice of problem? Case 3. Shall we go with A? Okay. Our choice is A. This is x is 4, y is 4, z is 4 times root 6. So this is 4 square plus 4 times root 6 square. Use calculator and your answer will be 8 times root 2. 8 times root 2. And now we will find theta. Tan inverse y over x. Y is 4, x is 4, both are positive, so there is no issue. Directly you will find tan inverse positive 1. Tan inverse positive 1 versus pi by 4, and obviously both the values of x and y suggest that you are in the first quadrant, so this is absolutely true. Theta has no issue. Finally, phi. Just type in the calculator, you will find cosine inverse z. Z is 4 root 6 over rho 8 root 2. You can simplify, but directly you can find from a calculator, because the calculators are allowed for the exam. 4 over just type it, you will get 30 degree or pi by 6 the calculator. Okay, fine, that's it. Now we go for the fourth case. Convert from spherical to rectangular coordinates. Case number 4. Convert to spherical to rectangular coordinates. Okay. The solution part, we will choose one problem. We'll choose one. A. Spherical coordinates are rho, theta, and phi. We have to find rectangular coordinates x, y, z. So the formula for x by using rho, theta, and phi. Rho sin phi cosine theta. Y is rho sin phi sin theta, and z is rho cosine phi. So when we choose problem A, rho is 1, theta is 2 pi by 3, and phi is 3 pi by 4. We use our calculator properly, so x is rho 1 Sine phi is 3 pi by 4. Be careful, do not use theta instead of phi. Phi is 3 pi by 4 and cosine 2 pi by 3. What do you get is, use calculator straight away. You must get cosine, and this sine will give you, so directly you will get negative 1 over 2 root 2. Second part, why? You can write this one in as negative root 2 over 4 is also equally good. Second, 1 sine phi 3 pi by 4 3 pi by 4 and sine theta theta is 2 pi by 3. Just type in the calculator, you will find root 6 over 4. Root 6 over 4, that's the answer here. Directly rho is 1 cosine phi. Cosine phi is 3 pi by 4 and the answer is cosine 3 pi by 4. What is it in the second column, isn't it? So you can write negative root 2 over 2. Otherwise you can write negative 1 over root 2, both are equivalent. Negative 1 over root 2, both are equivalent. So that's it. That's the way we can convert spherical to rectangular coordinate system. Next, phi. Convert from cylindrical to spherical coordinate system. Convert from cylindrical to spherical coordinate system. Let's write cylindrical coordinate system r theta z to spherical rho theta phi. So this is what we are looking for, rho phi. Rho, the formula of rho, there is no change in theta, remember. So the formula of rho should be written in terms of r and z, isn't it? So that is square root of r square plus z square. And the formula for phi by using r and z. Okay. The formula for phi, we have phi is tan inverse r over z, isn't it? That is it. Now substitute the values. That's all. Rho will be square root of r square. Where is r? What is your choice? Problem number 10 from the textbook. Actually in our count is 5. Let's choose A. It's looking good. Okay. Theta has no change. So theta is, this is r theta and phi given as r theta and z. Okay, r theta and z. So z is 4, r is 4, so 4 square plus 4 square. You can simplify and you can get the answer as 4 root 2. Theta has no change in both the coordinate systems, so it is 5 pi over 6. And the formula for phi says tan inverse r is 4, z is 4. So the answer is tan inverse positive 1, which is pi by 4. So the answer in the triplet form, you will is 4 root 2 5 pi over 6 pi by 4. That's it. And the final case number 6. Case number 6. It's to be discussed. Convert from spherical to cylindrical. Spherical coordinates are rho, theta, phi, and we are moving to cylindrical r, theta, z. So there is no change in theta. We have to find r and z in terms of rho and phi. And we have the formula for r. R is rho sine phi. Z is equal to rho cosine phi. So the formula suggests you that what is r? From 12, let's choose one problem. Let's choose C. So here rho is root 2, theta is 3 pi by 4, phi is pi. So no change in theta. So theta remains theta, which is 3 pi by 4. Isn't it? Therefore rho here root 2 sine phi, which is 0. Sine phi is 0, you get 0. And z is rho root 2 cosine phi. Cosine phi is negative 1, so you get negative root 2. Therefore the answer at the end we will rise at a order triple. What is it? R theta is it? R is 0, theta is 3 pi over 4, and negative root 2 is the value of z. That's the end of the conversion. All the 6 cases have been discussed right now. Now we are going to a different case. Next, an equation is given in cylindrical coordinate system. Express the equation rectangular coordinate system. Okay, we are going to convert. If possible, sketch it roughly. Okay, now this is r is equal to a sin theta, 4 sin theta, isn't it? Then equation is expressed by using r and theta. R theta z will give you cylindrical form. So the given equation is in cylindrical form. So we have to express the equation rectangular coordinates x, y, z. So we are moving from r theta z to x, y, z. No change occurs in z. So the formula for x is r cosine theta, y is equal to r sin theta. We should remember this, and that's it. And we have another rule connecting them is x square plus y square is equal to r square. We can use them. We are given r is equal to 4 sin theta. Multiply by r on both the sides. You get r square is equal to 4r sin theta. The r square is, as we know, this is x square plus y square. On the right side is 4 times y. From this these rules, the connection, the relation between rectangular and the cylindrical coordinate system, we will find this one. Now everything x and y, the answer is in x and y, isn't it? Convert this one to perfect square. You will get x square plus y square minus 4y is equal to 0. X square plus 4y, y square minus 4y, minus 4y, plus 4 minus 4 is equal to 0. We add and subtract a constant to get a perfect square of these 3 terms. So this is x square y minus 2 whole square, and this negative 4 on the right side, it will be positive 4, isn't it? We can write, now this is a circle whose center is 0, 2, radius is 2, but in 3 dimension it is a cylinder. cylinder. Okay, we are discussing three-dimensional space, so this is not a circle in three-dimensional space. This equation gives equation of a cylinder whose base is a circle, whose center is on the z. The graph is attached in this PowerPoint. You can find, you can roughly see the graph on the top here, like x, y, z, isn't it? This is x-axis, this is y-axis, this is z-axis. Your center is on y-axis. X is 0, y is 2, it is here. Center is, and the radius is 2 units. So you are getting a sphere like cylinder like this, whose center is on the y-axis. That is it for this problem. The next problem is problem number 31 from the textbook. An equation is given in spherical coordinates. So given in spherical, because rho and phi are involved in this equation, we know rho, theta, phi will give you spherical coordinate system. So one of the variables missing is doesn't matter. So this equation involves rho and phi at even one variable. If rho is 4, it is a spherical form, isn't it? So we need to know this one. Therefore, there are three variables of spherical coordinate. We have two here, rho and phi. We are going to convert into rectangular coordinate system x, y, z. Any known relation between these two can be used to get everything in x and x, y, z. Okay, fine. Rho, the relation between rho and x and y is rho square is x square plus y square plus z square. So we multiply rho on both sides with this equation. The given equation is rho is 4 times cosine phi. Multiply rho on both sides. Rho square is equal to 4 rho cosine phi. And we know z is equal to rho cosine phi. Therefore, this is x square plus y square plus z square is 4z. Just like the previous problem, convert into perfect square, you will get x square plus y square plus z square minus 4z is equal to 0, and then this can be converted into x square plus y square plus z square minus 4z plus 4 minus 4 is 0. So you will further find x square plus y square plus z minus 2 whole square is equal to 4. A sphere and the three-dimensional space whose center C is on 0, 0 and 2, and radius is 2, radius rho is equal to 2. This is a sphere on three-dimensional. Sketch the graph. How do you sketch the graph? Roughly try on three-dimensional space. Your point is on z-axis 2 units and the radius is 2, so it will go through this origin. So some sphere whose center is on z-axis with the radius 2. And that's it for this problem. An equation of the surface is given in rectangle. This is problem number 38 from the textbook, and 40, probably the last two problems. Okay, 38. Given in rectangular coordinates. So all the equations are in x, y, z. We have to convert first case in cylindrical coordinates, second case spherical coordinate system. Right? Okay. 38. First case, we are moving towards cylindrical coordinates, isn't it? Cylindrical. So what should I do is z. Take the square root of 3 as a common term, then you get under square root x square plus y square. So z is square root of 3r. This is it. Because the relation between x, y and r is root of is x square plus y square under square root gives you r. This is it. So second case B. From this equation we derive it. Z is rho cosine phi, and this is root 3 rho sine phi r. The formula for r and rho in terms of from cylindrical to spherical. Okay. Now when you divide by rho cosine phi, divide by rho cosine phi, you will get to divide by root 3 rho cosine phi. You will get 1 over root 3 is equal to tan phi, which will give you the phi value is pi by 6. Pi by 6. That's it. That is it. Only the phi value represents spherical coordinates. That's a pi by 6. It's a cylinder. I mean this equation of a cone you can find as a cone. In the introductory page you can find such an equation for cone. Okay, fine. This is for 38. Now we go for 40. A cylindrical. Now obviously this is x square plus y square is 6y. This is r square is 6r sine theta. Therefore r is equal to 6 sine theta when you divide by r on both the sides. This is in cylindrical form. And in spherical form b, r, just replace the value of r by rho sine phi, which is equal to 6 sine theta, and keep the rho in the left side, divide sine phi on both the sides. So 6 sine phi into 1 over sine 6 sine theta 1 over sine phi, and you know 1 over sine phi is cosecant phi. That's the end. So the answer is here 6 sine theta cosecant phi. That's the end. So now everything is in rho theta phi. So we are in the spherical coordinate system. That's it. That's the end of this problem. That's the end of this chapter 11.8. Thank you very much. Let's discuss the next chapter in the next video for this week. Thank you very much.